It's on. Hello, everyone. Welcome to the Scaling Atlassian track, if you haven't seen me speak already. This is our lightning talk for the summit, and I have Justin Thomas here, Atlassian's own, who's going to be talking about scaling Bitbucket and designing your instance to make optimal use of Git and Bitbucket. Quick fun fact about Justin is that he is an avid fisherman and fishes off the Sydney Harbor, and his favorite fish to catch is kingfish. So without any further ado, I know we only have 15 minutes, so I'm going to let Justin take it away. Thank you.
Good morning, everybody, and welcome to Bigger, Better Bitbucket. The goal of this talk is to help you understand how Bitbucket and Git work together, and use this understanding to scale Bitbucket as your organization scales, and also to have a stable deployment of Bitbucket so you don't get called out on weekends. So we'll start with understanding how Bitbucket and Git work together. Then we'll go through a list of things that you should look out for when you deploy data center, and then the monitoring and the alerting matrices that you should set up for a stable deployment, and finally, a few tips on deploying Bitbucket on AWS. So let's get started with Git's performance characteristics. So this is the Git's performance characteristics for a Git clone operation. So one of them is CPU, the other one is I/O, and the other one is memory. Can you guess which is which? So before joining Bitbucket's performance team, I was under the illusion, as you might be, that Git is I/O intensive. But it's not. Git is actually CPU and memory intensive. And for a clone operation, as you can see, Git can peg a whole CPU core for the entity of the operation. And the memory utilization is also really high. So that's 1.5 times the size of your repository on a disk, which is capped at 700 MB. And the I/O utilization, it's a bit strange. So it's a lot of small random reads and writes. So that's what you have to keep in mind. It's a lot of small random reads and writes. We'll get back to this when we talk a bit more about NFS and data center. Because of Git, Bitbucket is fairly unique. So along with the usual concerns of a web application like backup, security, SSL, database, you also need to look out for hosting operations. So what are hosting operations? Hosting operations are any operation that Bitbucket server does whenever you do a Git operation, like a Git push or a Git clone or a Git fetch. So hosting operations can be over SSH and over HTTP, and both of them have their own trade-offs. So in a usual web application, your concern is usually about latency. That's how quickly can you get your page in front of your user. You get your web page in front of your user. But for Bitbucket, along with the latency, you also need to think about throughput. That's the number of bytes of Git data that you want to push to your client. And that makes Bitbucket a bit more unique. And the other thing that you have to keep in mind is that UI operations can and do invoke Git processes on the back end. So when you view a merge diff on your pull request, or when you do a merge of your pull request, those operations do execute Git on the server. And then Bitbucket server also exposes REST endpoints, which your tooling can call. So if you call a REST endpoint, which is expensive, it can take a lot of resource on your Bitbucket server. And Bitbucket server also has webhooks, which Bitbucket server calls back for the triggers that you have configured. Now, hosting operations. So hosting tickets. So anyone who has administered Bitbucket for a given period of time, a long period of time, would have come across hosting tickets, right? Now, but what are hosting tickets? Hosting ticket is the mechanism that Bitbucket server uses to gracefully degrade the service. So since we know for any hosting operation that comes in, Bitbucket server, so there is a Bitbucket server part of it, and there can be one or more Git processes that are executed by Bitbucket server for a given hosting operation. And as we know that Git operations are resource intensive, so if Bitbucket allowed every hosting operation to go through, that would have cost your Bitbucket server to crash in a pretty ungraceful way. So to avoid that, what Bitbucket server does is that, so before a Git process is executed, it has to acquire a hosting ticket. And if it cannot acquire a hosting ticket, it's put on a queue where it waits till a hosting ticket is available. And if a hosting ticket is not available within a given period of time, your hosting request is rejected. So if you doing a Git clone and there is no hosting ticket available after a given period of time, it just times out. And till 4.11, Bitbucket server used to start up with a fixed number of hosting tickets, which was proportional to the number of cores that you have, number of cores that you have on your Bitbucket server. But with 4.11, Bitbucket introduced adaptive throttling. So what adaptive throttling does is that it scales the number of hosting tickets available on your system per core from a range of 1 to 12. So it keeps on sampling your CPU, and based on the CPU load of your system, it scales it up. So if your system is under immense load, it scales down the number of hosting tickets available per core, and if it's pretty light, then it scales it up. This is done because different type of Git operations have different performance characteristics. As we saw, Git clone is pretty intensive, but Git reflist or Git show command or history migration can be pretty low weight. So we can have multiple operations going around at the same time for a core. The next thing is build storms. So this is the number of clone operations that the production instance of Bitbucket at Atlassian handles. And this also happens to be one of the largest repository at Atlassian. This usually occurs because a build cascades and triggers other builds, and all of them try to clone the repository from Bitbucket at the same time. Now, given that what we know about hosting tickets and Git's performance characteristics, how does Bitbucket scale and handle so many concurrent clone operation? And you have to keep in mind that the production instance of Bitbucket at Atlassian has only 3 nodes. So what helps us over here is SCM-CACHE. SCM-CACHE is a mechanism which helps Bitbucket in scaling hosting operations out. So Bitbucket servers caches 2 types of hosting operations. One of them is ref advertisement, and the other one is clones. Ref advertisement is nothing but Bitbucket server telling your Git client or your build system that this is the list of refs, which is branches and tags, in a repository, and these are the commits that it's pointing to. And this is a lightweight operation, but it happens a lot because build systems usually poll Bitbucket server to figure out if there is a change in the repository or not, and to fire a build corresponding to that change. And so the SCM-CACHE gets invalidated if there is an update to your repository or based on a timeout. Another way to look at it is like this. So if you don't have a SCM-CACHE enabled, for n number of clone requests coming in, there would be n number of Git operations. Now, every Git process that gets created acquires a hosting ticket. Now, with SCM-CACHE there, for n number of clones coming in, you have only 1 Git operation getting executed. And that means only 1 hosting ticket acquired. So for all the other ones, there are no hosting ticket acquired. And what happens behind the scene is that the output of the Git executable is fed back directly to the n number of clone requests that came in, and it's also returned to a file. It's written to a cache file, which can be used for the subsequent clone request that comes in. And this file is invalidated if there is an update to your repository or based on your time. Now let's look at the resource utilization when there is a cache hit. So as you can see, the Git resource utilization is pretty low. The minor blip that you see in the beginning is because we had ref advertisement disabled, and the cloning was enabled for this operation. And the only major resource utilization was the I/O read, and that's Bitbucket server reading from the cache file and streaming it back to the client. One other thing that you should note is that ref advertisement caching is disabled by default, and that's being done because if you have a hook which can update the refs directly on disk, it can cause the ref advertisement cache to be stale. So if you don't have a hook which can update the refs directly on disk, please go back and enable ref advertisement caching. That would really help your system a lot because your build system polls the Bitbucket server for changes a lot. And the other way to handle this is to enable webhooks. So if you can enable webhooks, then your build system doesn't have to poll Bitbucket server for changes, but Bitbucket server can, in turn, call your build system and tell it that there has been a change. To sum it up, Git is a gobbler. It's really hungry for CPU and memory. Hosting tickets keep your system safe, and SCM-CACHE helps you scale your system. Now, let's talk about data center. So data center is a high-demand clustering solution that provides high availability, performance at scale, and instant scalability. But there are a few things that you should look out for when you are deploying a data center. So those are NFS, Hazelcast, and database. So when you move to data center, your Git repository moves from a local storage to a shared storage. And as we already saw, the Git's I/O performance characteristics is a large number of small random reads and writes. So you need to ensure that your NFS is capable of handling that. And if you don't have an enterprise storage, make sure the NFS server that you have deployed is capable of handling this large number of small reads and writes. And all these small reads and writes are network calls on your network. So you need to ensure your network is also capable of handling that. And secondly, Hazelcast. So the internode communication that happens between the different Bitbucket nodes is done using Hazelcast. And there's a lot of chatter going around between the nodes to keep them updated on the single source of truth. And so you need to ensure that the network that's between the nodes is a high speed and low latency, because Hazelcast needs that to do really well. And finally, database. So as you scale out with multiple nodes, the number of connections and number of connections coming into your database also increases. So you need to ensure that your database is capable of handling the connections coming up from all the different nodes. And let's talk about monitoring and alerting. So Bitbucket server exposes a lot of internal data, like what's happening inside the system, like the pulls, pushes, CPU, network traffic, database connection, all those on JMX. So you should definitely have JMX enabled and build a dashboard with all these metrics. You usually need a third-party tool to build this metrics, but what this helps with is that it gives you a historical view of what's going on with your system. Like, is there an increase in pull requests, or is there an increase in pulls and pushes per second? So this also helps you in capacity plan your system. Access logs is one of the least utilized feature, and it's really amazing. So, and this ships by default with Bitbucket server. So what Bitbucket server does is that for every request that hits Bitbucket server, there is a log entry in the access log. And it has a whole bunch of information that you can use to debug any of your issues. Like, it tells you what was the protocol that was used for the request, what is the user, what was the operation, how much bytes was written in. And most importantly, for hosting operations, you can also figure out whether the hosting request that came in was a cache hit or a cache miss. So if you have a lot of hosting operations coming in from your build system and they are not cache hits, then you need to look out and figure it out why it's not hitting the cache, because that's using a lot of your resources. And finally, alerting. You definitely should have alerting set up. And the only thing that I would say is that you don't need alerting for everything, because that can lead to a lot of false positives and negatives, which you don't want. But the most important alerting that you should have is disk space. Bitbucket server, as it uses Git, if it runs out of disk space, it can cause your repository to be corrupted, and you never want to do that. So definitely have alerting set up for disk space so it never runs out of disk space. That's it. To sum it up, with the proper monitoring and alerting, you can increase your uptime, respond faster to incidents, and plan for the future. And finally, let's talk about AWS. At Atlassian, Bitbucket server deploys its production instance on AWS, and we have a pretty good experience with AWS. Bitbucket server uses Amazon's RDS as well as Elasticsearch service, and both of them have been performing well for our needs. One of the frequent questions that we get for AWS is that whether EFS is supported or not. And the answer is no. As you saw, the I/O characteristics of Git is large number of small reads and writes. And EFS doesn't perform well for Git operations. So if you are going to deploy in AWS, make sure you deploy your own NFS server, and which is resourceful to handle it. And the other things that you need to look out for is throttling that AWS does. So network throttling as well as CPU memory throttling. So you need to provision your hardware in such a way that it doesn't throttle the operation that Bitbucket server wants to do. To wrap it up, as you all have, I think, a better understanding of how Git works and how Bitbucket uses Git to do all these operations. So please go back and set up the required monitoring and alerting so you have a better understanding of what has been going inside your system whenever there is an incident, or if there is a spike of, or there is a hosting ticket getting queued up. Yep, thanks you, that's for me.
Thank you.